Now, we can also apply our knowledge on solving systems of equation in network analysis. Networks are composed of branches and junctions and are used as models in such fields as economics, traffic analysis, and electrical engineering. In a network model, you assume that the total flow into a junction is equal to the total flow out of the junction. So somehow, this reflects the conservation principle. For example, we will have in figure 1.6 a network, and we're asked to set up a system of linear equation that will represent the network. So, and then solve the system. Now, what we can do here is to mark the junction. So the first thing that we need to do is to mark the junction or nodes. Say here, this is junction 1, junction 2, junction 3, 4, and 5. And then we apply the conservation principle. That is, inflow will be equivalent to outflow. Okay, so applying the conservation principle, you will have inflow is equivalent to outflow. Say at junction 1, so what happens at junction 1? We see here that the inflow is actually 20 and the outflow is given by x sub 1 and x sub 2. So we can write there x sub 1 plus x sub 2 is equivalent to 20. Now let this be our first equation. Let's say at junction 2, say we will have at junction 2, inflow would be x sub 4. Say at junction 2, we will have an inflow of x sub 4 and an outflow equivalent to x sub 3 and 20. So we will have x sub 3 plus 20, or say we will have a negative x sub 3 plus x sub 4 is equivalent to 20. Let this be our second equation. And again, for, let's say at junction 3, what will be the inflow? We will have x sub 2 plus x sub 3. X sub 2 plus x sub 3 is simply equivalent to 10 plus 10, or that's equivalent to 20. Let this be our equation 3. And for at, say at junction 4, okay, at junction 4, what do we have? An inflow of 10 and x sub 1. So we will have here x sub 1 plus 10 is equivalent to x sub 5. So let this be our equation 4, or improving that one, we can rewrite it as x sub 1 minus x sub 5 is equivalent to negative 10. So let this be my fourth equation. And finally, at junction 5, okay, we will have the inflow as x sub 5 plus 10 is equivalent to x sub 4, or that will be negative x sub 4 plus x sub 5 is equivalent to negative 10. Let this be my equation 5. Now, combining everything, now let us have that one so we can have the system of equation. Then we will have your x sub 1 plus x sub 2 equivalent to 20. And for equation 2, we will have a negative x sub 3 plus x sub 4 is also equivalent to 20. Equation 3, we will have x sub 2 plus x sub 3 equivalent to 20. And for equation 4, we will have x sub 1 minus x sub 5 is equivalent to negative 10. And finally, we will have negative x sub 4 plus x sub 5 is equivalent to negative 10. Now, rewriting everything into the augmented matrix. So what do we have? We will have 5 equations in 5 unknowns. So say we will have here 1, and then 0, 0, as well as 1 and 0. And then we will have 1 for x sub 2, 0 here, and then we have 1, and then again that will be 0, and then we also have 0 here. For x sub 3, this is 0 here, and then we will have negative 1, positive 1, and then 0, and then 0. And for x sub 4, we will have here 0, and then 1, and then 0, and then again another 0, and negative 1. Finally, for the coefficients of x sub 5, so you have your 0, 0, 0, negative 1, and positive 1. And of course, the constants, which are 20, 20, 20, negative 10, and negative 10. Now, since we're able to set up the system of equation as well as augmented matrix, we are ready to apply our Gaussian elimination with back substitution, or proceed with backward phase so that we can convert the matrix into a reduced row echelon form via the Gauss-Jordan elimination. Okay, now let us see what will be the result of this solution. So as you can see, this will be the model. Okay, this will be the system of equation. So we have here the conservation principle at different junction, and we come up with the augmented matrix for the system. And then by applying Gauss-Jordan elimination, the reduced row echelon form will have the following. Notice that we ended up with a row of zeros, okay, which, okay, we were able to see here. This signifies, so whenever we ended up with a row of zeros, this signifies that the system will have infinitely many solutions. So it's understood that the column 1 is a coefficient of x sub 1, and then column 2 are coefficients of x sub 2, column 3 are the coefficients of x sub 3, column 4 are the coefficients of x sub 4, and column 5 are the coefficients of x sub 5. If you're going to look at row 4, okay, if you're going to look at row 4, we will see here that we will have x sub 4, okay, x sub 4 minus x sub 5 is equivalent to 10. So basically, it seems that x sub 5 can be treated as a free variable so that we can express x sub 4 in terms of x sub 5, or that will be 10 plus x sub 5. Okay, so you see here x sub 4 minus x sub 5 is 10. So that means we can express x sub 4 as 10 plus x sub 5, and then we are going to treat x sub 5 as a free variable and allowing it to be equivalent to a parameter t. So let's say t is any real number for now. Okay, since, okay, so let's say we don't know the restriction yet for t. All we know that t is, it can be a number, right? Any real number. So looking at row 3 now, okay, we see the expression that x sub 3. So with row 3, we see that x sub 3 minus x sub 5 is equivalent to negative 10. So that x sub 3 is equivalent to negative 10 plus x sub 5, or that will be x sub 3 is negative 10 plus t. Okay, so you have your x sub 3 minus x sub 5 is negative 10. Or since x sub 5 is t, then x sub 3 is negative 10 plus t. And then considering your row 2, we will have x sub 2 plus x sub 5 is equivalent to 30. So here, x sub 2 plus x sub 5 is 30. Therefore, x sub 2 is simply 30 minus x sub 5 or 30 minus t. And finally, for your row 1, we will have x sub 1 minus x sub 5 is equal to negative 10, or that x sub 1 is equivalent to negative 10 plus x sub 5. So if you're going to show the solution, or this is equivalent now to negative 10 plus t, so this will be your x sub 1. So x sub 1 now is negative 10 plus t, x sub 2 is 30 minus t, x sub 3 is negative 10 plus t, and x sub 4 is equivalent to 10, that will be, okay, what is x sub 4? That is simply 10 plus t, right? X sub 4 is simply 10 plus t. And then, of course, x sub 5 being t. Okay, now let's see our answers here. So where t is any real number, so this system has infinitely many solutions.